Hey, this is the second video for the new technique of solving quadratic equations. So last week we solved quadratic equations by graphing, and we checked those solutions by solving by factoring, and we also learned a method called square roots. This entire week is going to be spent with completing the square. And that special pattern you saw in the opener is going to come into this method. So the very first problem here is this is written as a perfect square. So if we multiply it out, remember this is x plus 3 times x plus 3. You don't need to write that if you don't need to see that. And if we multiply, FOIL or whatever method you prefer, we'll get x times x is x squared. X times 3 is plus 3x. 3 times x is plus 3x. And then 3 times 3 is plus 9. So, and take note, if this is written this way, the outer and the inner terms will be the same, and they will combine, and you will get x squared plus 6x plus 9. Because recall that the perfect square trinomial pattern was this a plus b quantity squared equals a squared plus 2ab plus b squared. So you see that this 9 is 3 squared. You see this x squared is this x squared. And then the middle term here, 6x, is 2 times that 3 times that x. So that middle term becomes important. So if we wanted to see what this 9 should have been, you could take this 6, divide it by 2, you will get 3, and then square it, and you get that 9. So that's a way to recover the 9 and see where to recover the 3 and see where the 9 comes from. So dividing the coefficient of the x term or the linear term by 2, that's what I just did right here. Then you square that result to get the constant term. Okay, so here we have x minus 4, quantity squared. You could think of that as x minus 4 times x minus 4. And if we multiply this out, x times x is x squared, x times negative 4 is minus 4x, negative 4 times x is minus 4x, negative 4 times negative 4 is positive 16. And the two middle terms, again, are the same, and they combine x squared minus 8x plus 16. And if you look back at this pattern that's up here, my final term, 16, is this negative 4 squared. My first term, x squared, is this x squared. And then we have that middle term. And if we want to recover the 16, we take the negative 8 divided by 2. You get the negative 4, and square that, and you get the 16. Take note, this negative 4 is what's right here in the factor. So, we're going to see expressions of the form x squared plus bx without the c. That's not a perfect square. However, we're going to learn what we need to add it. So if I just had x squared minus 8x, that's not a perfect square trinomial. And if I want to make it a perfect square trinomial, I would take negative 8, divide by 2, take the negative 4 then, square it, and add 16. This is going to be called completing the square. So that would be if I started with x squared plus 6x and plus c. And if you want to find the c, you take the 6, you divide it by 2. You'll get 3 and square that, and you get a perfect square trinomial of x squared plus 6x plus 9. This is what completing the square references, this technique. So it's going to be a technique to solve some more quadratic equations. Now, one thing you're going to see, I only like this technique when a is equal to 1 and b is even. The reason I want b to be even, if you see down here, I'm dividing by 2. It's much easier if that's just an integer. You can solve it if these are not true, and we're going to see both of these not being true at times. But if I'm choosing a method and I'm considering completing the square, I want a to equal 1 and I want b to be even.